use. Now, no, you can't use it on your test. This is what you need to remember. But all of these things can be used as reasons in our proofs, and we're just going to talk about how they would relate to angles, okay? So first of all, just to refresh, our properties of equality that we have talked about many times before are the addition property, subtraction, multiplication, division, distributive, substitution, reflexive, symmetric, and transitive. And then there were only 3 of them that we could use if our signs were congruent instead of equal to, and that's the reflexive, the symmetric, and the transitive. Okay, again, nothing new. We've talked about all of that before. Some definitions that we are going to want to look at as far as they are concerned with angles. Okay, you remember how we used definition of congruence a lot with segments? We could say that 2 segments were congruent, and then we said that they were equal to each other. So the very same thing we can say there with angles. All right, so if they are equal to each other, it's going to look like this. It's going to have M in front of it, so the measure of angle A equals the measure of angle B. And then you can say that if they are equal, then angle A is congruent to angle B, and you need to take note of how they are written. And of course, those can go back and forth. So you can tell me that they're congruent, therefore they're equal. But if they're equal, you put an M in front of your angle symbol. So the measure of the angle is equal to the measure of the angle. You're talking about how many degrees they are. Whereas without the M, it's angle A is congruent to angle B. That means same size, same shape. Okay, so definition of congruence can be used with angles as well as segments. Is everybody okay with that? Sure, okay. Then you have the definition of an angle bisector. These are all reasons that we would use in our proofs. Okay, let me take a timeout. For reasons in our proof, the definition of congruence we just talked about. The definition of an angle bisector, and an angle bisector says that it divides an angle into 2 equal parts. Technically, scratch out equal, it should be congruent. Everybody scratch out equal and put congruent. So if I say that you have an angle bisector, what you should be able to tell me is 2 congruent angles. Okay, so if I tell you that you have an angle bisector, what you would then be able to tell me is that you have 2 congruent angles. Okay? Then if you are told or that you can see that 2 angles are complementary, and how would you see that is maybe if you had a picture like this and you had the little box there, you could tell that those 2 are complementary, right? But complementary angles add up to be 90 degrees. So if I say that A and B are complementary, then you could say the measure of angle A plus the measure of angle B equals 90 degrees. Or if I tell you that 2 angles are supplementary, then you would be able to tell me that those 2 angles add up to be 180. So again, if I said angle A and angle B are supplementary to each other, you would be able to say that the measure of angle A plus the measure of angle B equals 180 degrees. The definition of perpendicular, if I were to tell you that 2 lines were perpendicular, you would then be able to tell me about some right angles. Okay, you would be able to name some right angles from that. Okay, so for example, if I said, let's say AB and BC, if I were to say that those are perpendicular, then you would say that angle ABC is a right angle. Okay, so if I tell you you have 2 perpendicular lines, you should be able to name some right angles. Okay. Ever. Okay. And then the next one is a definition of a right angle. So if you are able to name a right angle, then you should be able to tell me that that angle is equal to 90. So, for example, if I were to say that, if I were to give you angle A is a right angle, whoops, then you would be able to say that the measure of angle A, would help if I write that properly. The measure of angle A equals 90. Okay, so again, if I say something is a right angle, then you should be able to tell me that that angle is equal to 90 degrees. So those are all definitions that we can use as reasons in our angle proofs. Definition of congruence, definition of angle bisector, definition of complementary, definition of supplementary, definition of perpendicular, and definition of a right angle. And then we have some postulates. The angle addition postulate is very similar to the segment addition postulate, and that just basically says that if I take two angles and add them together, so for example, in this picture, the measure of angle ABD, so that's this little angle right here, plus the measure of angle DBC, that's this little angle right here, equals the measure of angle ABC, which is the whole thing. So basically you're adding two angles together to get a larger angle. Okay, so that's what this segment addition angle addition postulate says. And then we have some theorems. The vertical angle theorem. Basically, what do we know about vertical angles? They are always congruent, okay? So if you are given a pair of vertical angles, then you are able to say that those two angles are congruent. Then you have the complement theorem that says if two angles form a right angle, then they are complementary. Similar to that is the supplement theorem. If two angles form a linear pair, then they are supplementary. And I don't usually call it the supplement theorem. I just say, like if I give you a picture of a linear pair, I say angle A and angle B are a linear pair. Therefore, then I can say they are supplementary. Okay. And then again, these last two, I don't necessarily refer to them when I'm writing my reasons and my proofs as these names. Congruent complements theorem basically says that if angle A is complementary to B, okay, so let's do this. Let's say that we have angle A here, and that is, let me draw it a little bit bigger. So if I have angle A, and I say that that angle is 20 degrees, okay, and then I have angle B, and I say that is 70 degrees. Those two are complementary, right? They add up to be 90. Yeah? Okay. So if angle A is complementary to angle B and angle C, okay, so let's do C over here, and that is also 70 degrees. A is complementary to both B and C. Then what that tells me is that, oh, I just read that wrong, my bad. I didn't finish reading the sentence. So it says, if A is complementary to B, sorry, y'all. Erase all that. And then it says that C is also complementary to B. So that means what would C have to be if it's complementary to B? B is 70. What would C have to be complementary? What adds with 70 to give me 90? 20. Okay. So if A is complementary to B and C is also complementary to B, then by this postulate, A and C have to be congruent. Okay, so if A is complementary to B and B is complementary to C, then A and C have to be the same thing. And then the congruent supplements theorem says the same thing, except for it talks about there being supplementary. If A is supplementary to B and C is supplementary to B, then A and C are congruent. So basically, if you have two different angles supplementary to the same angle, then those angles are going to be congruent. Okay, so all of this whole front page can be used as reasons in our proofs. Are we ready? Sure, can't wait. So excited. Okay. Glad to hear that. Flip it over. I'm actually going to do this on the board because I just don't have a lot of space to write it up here. Draw my picture first. All right, so it gives me that angle ABE and angle DBC are right angles, correct? Okay. And it wants me to prove that angle ABD is congruent to angle EBC. Okay. So it has that box there, but it also has that box right there, correct? Yes. Okay. In a proof, what is my first statement and my first reason always going to be? So let's go ahead and get that set up. Okay, so what I want to know is what the first statement tells me that I have what kind of angles? Right angles. Okay, so flip over on the other side of the paper. Find the right angles. What does it say in the definition of right angles? It says that the angle would then equal 90. So since it is telling me that these two angles are right angles, then by the definition of right angles, the very next thing I need to say is that those two angles equal 90. So this is how we do it. We start with the first one. The measure of angle ABE equals 90. And then also the measure of angle DBC equals 90. And what was that definition we just used? The definition of right angles, yep. Because I was told they are right angles, I'm able to say that they both equal 90 degrees. Now, what two angles am I supposed to get into? What two angles do I need to be able to prove this congruent? ABD and EBC. So are those in my proof yet? Okay. Let me ask you a question. Since they both equal 90, could I say that the two angles are equal to each other? Okay, so let's do that next. Let's say that the measure of angle ABE equals the measure of angle DBC because they were both equal to 90. So we can call this one of two properties. Look at your properties at the top. The properties of equality is what we're looking at. Either one would be sufficient. Substitution would work, yes. The other one could possibly be transitive, but substitution would work here. All of that came from my first statement, came from the fact that those two angles were right angles. But keeping in mind, we've got to be able to bring in ABD and EBC. Let me ask you this. Look at your picture. What else can you tell me about ABE? ABE. What can you tell me about this big angle? What is it made up of? This is a right angle? Yeah, which we already said, because that's what was given to us. But let's imagine that this is not here. What can you tell me about that angle? What is it made up of? ABE, this big angle, what is it made up of? ABD plus, how do I call this one? DBE. So what I can say then is that the measure of angle ABD plus the measure of angle DBE equals the measure of the big angle, which we called it ABE. Does everybody see that? ABD, so this small angle right here, plus DBE, this small angle here, add to give me that big angle. Yes? Let me put this back now. Now I want to pretend like this is not here. What can you tell me about DBC? What is it made up of? Yes. DBE, so this top angle here, plus EBC, this bottom angle here, can add together to equal the big angle. And that's the same reason, so I'm going to put it in the same sentence. The measure of angle DBE plus the measure of angle EBC equals the measure of angle DBC. What rule says I can add two angles together to get a bigger angle? Angle addition postulate, yes. So much like the segment addition postulate, except for we're referring to angles here. Okay, now, this looks confusing because we got all these letters involved. You just have to remember that we're talking about angles, and each little set is going to have 3 letters in it. Don't let that confuse you. So far, so good? Did we get ABD and EBC in our proof somewhere? I did. Okay, so now what I have to do is try to see about getting them on opposite sides of the equal sign so that I can then say that they're congruent, hopefully. So look at steps 3 and 4. ABE, did we not rename that? Didn't we say that that was equal to something else? What did I say it was equal to? So what I'm going to do is I'm going to take that ABE out, and I'm going to replace it with what it's equal to, which is the measure of angle ABD plus the measure of angle DBE, and I'm running out of room, so I'm having to write small, I'm sorry. And then if I take out DBC and replace it with what it's equal to, so that's the measure of angle DBE plus the measure of angle EBC. Oops. And what says I could take something out and replace it with something else? Substitution. have to come over here because I just don't have enough space. Does anybody notice in step 5, what do I have the same on both sides of my equal sign? Angle DBE. So can we take that off of both sides? Yeah, how would I take it off? Subtract it. So if I were to subtract this DBE from here and here, they basically just disappear, right? So I would be left with the measure of angle ABE. Nope, I'm sorry, ABD is equal to the measure of angle EBC. And we did that by subtracting. Is that what I was trying to prove? Is it close to what I was trying to prove? Yeah. If they're equal, can I now say they are congruent? Yeah. So then I can just say that angle ABD is congruent to angle EBC because of the definition of, to go from equal to congruent, that's the definition of, yeah. So it seems like a lot, and it does seem a little confusing because of all of the letters, but you have to just take it slow, talk about how to incorporate what you need. We use angle addition and segment addition a lot, especially in these beginning proofs. Anybody have any questions on those? All right, let me see something. Okay, we're going to do the next one. I'm trying to decide which one I wanted to skip because we won't be able to do all of these. Is everybody ready for the second one? Sure. Okay. Set it up. Our first one is our given. That given says that angle 1 and angle 3 are supplementary, and I'm going to abbreviate because I don't have enough space. Oops. What I'm trying to prove is in that picture, I'm trying to prove that angle 2 and angle 3 are congruent to each other. Okay. So right now, all I have is that angle 1 and angle 3 are supplementary. So here's my question. If I know that 2 angles are supplementary, what does that tell me? They add to equal 180. So if I tell you that angle 1 and angle 3 are supplementary, then the next thing you should be able to tell me is that the measure of angle 1 plus the measure of angle 3 equals 180, right? Okay. And why is that? The definition of? What did they tell you the angles were in the first step? Angle 1 and angle 3 are supplementary. And so to say that they're equal to 180, that's the definition of supplementary. Did I bring angle 2 into play yet? Is angle 2 listed in my proof anywhere? No. Okay. And I don't really have any other given information to use. They told me they were supplementary, so I was able to say, okay, well, I know they had to be 180 from there. So what I need you to do is look at your picture. can you tell me anything from that picture about angle 2? It's what? Well, we're trying to prove that. We don't know that yet. We're trying to prove that. What else can you tell me? Oh, I don't have a 4. It's touching 1, okay. All right track. Yes, ma'am. Okay. How do you know angle 1 and angle 2 are supplementary? What do they form? A line. What's the word for that? A linear pair. Okay, so yes, from my picture, I can say, if my pen would write, maybe, come on. I can say that angle 1 and angle 2 are supplementary. And the reason for that is because I can look at my picture and I can tell that those two together give me a straight line, which is called a linear pair, right? So like the definition of a linear pair, or I usually just put linear pair. Anytime you see linear pairs, you can say that they are supplementary. Okay, here's a question. Kind of like I did from 1 to 2. If 1 and 2 are supplementary, then you should be able to tell me that they add to equal 180. So the measure of angle 1 plus the measure of angle 2 is equal to 180. And much like the reason for step 2, that's the definition of supplementary. Keep in mind, I'm still trying to get that 2 is congruent to 3. So I've got to get an equation at some point with 2 and 3 on opposite sides of the equal sign. Quick question. Look at step 2. What does it tell me about 1 plus 3? What are they equal to? 180. And then look at step 4. What does it say 1 plus 2 are also equal to? 180. So could I say then that the measure of angle 1 plus the measure of angle 3 is equal to the measure of angle 1 plus the measure of angle 2? And what reason? If they're both equal to 180, I just did what? I substituted. You could also call that the transitive, but we can call it substitution. Do I have 2 and 3 on opposite sides of the equal sign now? Yeah. What's the same on either side? Angle 1. Can I take angle 1 away? Yes, by doing what? Subtracting. So then that's going to be the measure of angle 3 equals the measure of angle 2. That is subtraction. I can switch them. Do I need to switch them? Yeah. Okay, so let's go ahead and switch them. So the measure of angle 2 equals the measure of angle 3. And that is, what's that property called that switches it? Symmetric. Right, to just replace the order? Yeah, symmetric. Okay. And then one last thing. Right now I have they are equal, but my proof statement wants me to say that they are congruent. So can I just say then that angle 2 is congruent to angle 3? And that's the definition of congruence. All right, what I want you to do is skip down to that bottom one. Do you notice how I gave you your statements and I'm just asking you to fill in your reasons? Yes? Okay, so skip the third one, go down to the bottom one. I want you to see if you can fill in those reasons. Given the statements, let's fill those reasons in. Okay, we're skipping number 3. going all the way down to that last one. I gave you the statements. I want you to fill in the reasons for 2, 3, and 4. Keep in mind that all of that is congruence. So think about the properties that you can use with congruent. To figure out step number 2, you might need to look at your picture and to try to decide, why is it that I can say that those are congruent? What kind of angles are they that lets me know that they are congruent? And then from there, saying that 5 and 7 are congruent, look at your list of congruent properties. There are only 3 of them. It's either reflexive, symmetric, or transitive. You have to figure out which one of those you can use to justify that statement. And then the same thing with step number 4. Which one? Reflexive, symmetric, or transitive? I was given that 4 and 7 are congruent. And then I'm told that 5 and 4 are congruent and 7 and 6 are congruent. Why are 5 and 4 and 7 and 6 congruent? What kind of angles are they? Vertical. So we just say that vertical angles are congruent. Okay, or you can say the vertical angle theorem if you want to. You can just say vertical angles are congruent. So it says that 4 and 7 are congruent. Then it says 5 and 4 are congruent. Then it goes to say that 5 and 7 are congruent. Is that the reflexive, the symmetric, or the transitive property to say that one is congruent to this one is congruent to that one, so therefore these are congruent? Reflexive, symmetric, or transitive? Transitive, yes. Okay, we can't use substitution here because it's congruence. But transitive is much like substitution. And then because 5 and 7 are congruent and 7 and 6 are congruent, then I can say that 5 and 6 are congruent by what reason? Reflexive, symmetric, or transitive? If 7 is congruent to 6 and 7 is also congruent to 5, then I can say that 5 and 6 are congruent because transitive, yes. Does that make a little bit of sense, sort of? Transitive means like this one is going to be congruent to this one, and then this one will be congruent to a second one. So then the two, yeah. Is everybody okay with that?